sketch the graph of an exponential function of the form y equal to a to the power x, where a is greater than 0. And so we will be going through the equation itself, and you will see how it will look on the graph. We'll also discuss the form. Now, the objective is over here. You need to be familiar with the function y equal to a to the power x, where a is greater than 0, and to know the shape of its graph. And so this is the whole objective behind this tutorial. As an example, look at the table of values for y equal to 2 to the power x. As you can see here, for every x, we have the value of y. When x was minus 3, y was 1 over 8, and so on. And so here we have this table of values that is going to be really helpful while we go ahead and present it on the graph. Now, in the expression such as 2 to the power x, the x over here can be called a power or an index or an exponent. And so we're talking about the x that is right on top of the 2. You will see in section 3.2 that it can also be thought of it as a logarithm, and we will discuss that later. A function that involves a variable power such as x over here is called an exponential function. Now you're going to see how the exponential function will look on the graph by the end of this video. And so moving on, let us also discuss something else concerning the exponential functions. Here we have our example, y equal to 2 to the power x. Now note that 2 to the power 0 is equal to 1. In fact, a to the power 0 is equal to 1 always if a is greater than 0. And for the first one, 2 to the power minus 3 is equal to 1 over 2 to the power 3, which is 1 over 8, as you can see here. A negative index implies the reciprocal of a positive index, which is exactly what we did here. Notice that the sign of the power minus 3 switched to 3 once it moved down to the denominator. And so this is what we call the reciprocal. Now, let us go ahead and plot these points on the graph to see what they look. We're going to go ahead and see how this exponential function right here looks on the graph, and we will study its properties. Notice that here, for every value of x, we have a value of y. So let's plot them. Now, as you can see here on this graph, notice the first value of y is equal to 0.125. The second one is equal to quarter. The third is equal to half. Notice its relevance on the axis. Here we have for x equal to 1, y equal to 2, for x equal to 2, y equal to 4, and for x equal to 3, y equal to 8. Now this is basically an exponential function. You can notice straight ahead that in such case the x-axis is an asymptote to the curve. The curve gets as close as possible to the x-axis but never intersects. And you can notice at the very beginning on the very left of this graph, the curve is actually close. Other graphs of the type y equal to a to the power x are similar, always passing through 0 and 1. So this is basically another property for the other types of curves that have the equation y equal to a to the power x. Again, they will have the x-axis as an asymptote, and they will look like this curve right here.